I will be presenting technology on advanced CNC micromachining system developed at IIT Delhi, and this unique development is funded by Department of Science and Technology. It's a unique machine that we have developed at IIT Delhi, which has a capability of micromachining multiple materials actually, and the different shapes can be machined. This is one of its own indigenous development that has happened at IIT Delhi, where we have integrated multiple conventional and unconventional machining processes. Because when we are going to produce micro components and machine small elements, we need to have conventional processes like milling, grinding to be performing these operations. Along with that, we'll also be combining the unconventional machining process, because many difficult to machine materials like titanium, zirconia, they can't be easily machined by the conventional tools. So we have integrated in this machine two unconventional processes. One is laser beam machining, another is on the electric discharge machining. So these are the unique developments, and we have integrated all these machining tools into one integrated tool head. So that's a unique development. Along with these machining heads, we also integrated metrology and the force measurement systems, because that's a very important part for making any micro machine components, because we need to do an in situ measurements. The results, the outcome of the machining should be monitored continuously within the machine itself, because the idea is to micro machine the whole component in one setup. So if we are going to perform multiple operations, multiple processes are going to operate on a single component, we will like to have one single setup, because changeover will be disturbing the microgeometry. So that's an important part of this development. Yeah, machine tool development is a very important requirement for Indian manufacturing industry, because indigenous development of such a 5-axis CNC machine is a very important development that we have done. And in this case, the another process that we have come out with is a dry EDM, that is a dry electric discharge machining. Normally electric discharge machining is performed with the liquid dielectrics. In this case, we have attempted to use multiple gases as a dielectric, because the rest of the machine has to be in a dry environment and the other processes being performed in the same machine tool. So we would like to use the gases as a dielectric for discharging electric discharge machining. In this process, we will be continuously monitoring the forces that are coming on the component, because that's a very important for micro machine components. Any force which is going to affect the geometry of the workpiece is continuously monitored actually. So that's how we have integrated the 6-axis dynamometer within the machine tool itself, along with the optical microscope. When it comes to the development of a CNC machine, and with so many processes in operation, the bigger challenge is how we'll integrate the controllers of the multiple processes in one single HMI, that's an human machine interface. Because operator is going to operate through one single interface, the multiple processes are being controlled. So the complete software, the control software is being developed within the lab only, where we will be able to write the part program integrated with the requirement of a different machining processes. And that's again a new development that has happened indigenously within the lab only. Here we are able to manufacture the component, and as well as we will be able to do certain post-processing within the machine itself.
Hello everyone. So this is Advanced CNC Micromachining System. This is a DSC sponsored project. It is basically a 5-axis CNC micromachining system having 5 different micro machining processes integrated in a single machining setup. So this first is micro milling. So it is basically a air bearing spindle running on air, pneumatic air, with having 80,000 RPM speed. This is laser cutting head, and this is for micro EDM. So this 5-axis CNC machine has basically 11 different axes integrated in a single machine. So corresponding to individual processes, we have different secondary axes, and individual process can be integrated and can be used in a single time. So a sequential functioning as well as independent functioning is available in this machine. This machine also has a force sensor for basically a dynamometer, a 6-axis dynamometer having 3 forces and 3 torque measurement system, and a 256 zoom microscope integrated into it with a confocal sensor for measuring surface roughness. So this is basically a distance measuring sensor which has been calibrated to get a roughness value. This is basically a GUI for this machine. So this GUI showcases everything about the position and the acceleration data So it has basically 4 different operation modes integrated in a single machine. So first is the automatic mode. So in this automatic mode, we have an option to directly input the NC file. So that NC file can be selected from a list of files, and once we select the file, we can edit it here in this GUI. So that is available. Second, we'll move forward towards the manual mode. So this manual mode has further 3 different modes. First is the tip mode. Tip mode is basically a continuous mode where all the slides move till the plus and the minus sign is this. Plus and minus sign indicate the positive and the negative direction for this motion. Then we have a jog mode. Jog mode is specifically to move the machine in a specific increment. So here 4 different types of increments are available: 1 micron, 10 micron, 100 micron and 1000 micron. And last one is the hand wheel mode. So basically it is basically a pendant. So if that pendant is connected, so through that we can move the machine. In this manual mode, further we have option to change the velocity for this motion axis. Moving towards the MDI mode, so this is basically a single axis of code. So if we input a single line of code, so through that the machine can function. Basically it is basically for checking or doing some testing work. So that is this is for referencing the machine. Then moving towards the manual mode, further these in the automatic mode, further this start function, stop function and the reset function, these 3 buttons are available. This is for starting the NC code. So once we input the NC code, with the help of this start button, if we press the start button, the machine will start it functioning. Through this, in case of emergency, we can stop the machine, and reset will reset all the errors, or the current position is also reset to 0. Then we have a homing button available on this side. So this is basically to home the machine or 00 all the axes. So that can be done. Like if you press the home button, all the axes will be 0. So all the axes, as you can see, all the axes are 0. Then we have a single block of code. So if we want to run the machine a single block of code, that can be done. If we want to ignore the single line of code, that can be done. And the stop enable, this is basically for emergency enabling. So through that it is available. If we have cycles of code, so that can be input with the help of this machine. Then we have a tool table. So in this tool table, various kinds of tools are available, so that all the specifications for that tool can be input, and that can be used while changing the NC code. So that is available. And then we have an enable or disable command. So through this, first we start with the enabling, and then we'll input all the process and everything can be done. Further, we have for the process and the individually process control, or individual heads can be controlled with the help of these specific GUI which has been integrated into this machine. So through various kinds of software, this can be controlled, and all the measurement data can be taken with the help of individual softwares which are linked to this GUI. So now this shows the milling action. So now we are starting, we have uploaded up NC code, and now the milling will start. As you can see, the milling tool is moving at 40,000 RPM, and the cutting is done for 10 mm of linear cut. So that linear cut is done. Now it is moving in 3 different axes.
This is a micro electrical discharge turning setup in which we can fabricate axisymmetrical components of any conductive material. This micro electrical discharge turning is based on the micro EDM, on the working principle of micro EDM. And this is having a customized electrically isolated EDM spindle. This is the spindle, and it is also having a customized EDM power supply which can be suitable for a micro EDM process. The anode and cathode from the EDM power supply is connected to this block electrode and rod electrode. The rod electrode is connected to the anode terminal of the power supply, and block is connected to the cathode terminal of the power supply. This nozzle is used to supply the compressed air and gases directly to the machining area for dry condition. We are using a CMOS camera for taking the live feed and do the measurement of the rod in between the process. This extra X slide is installed on this micro EDM setup to achieve the micro electrical discharge turning for the fabrication of electrodes. On the screen of PC, live feed of machining process is coming, so that we can measure the electrode fabrication in between the process. Hello everyone, this is Hardik Patel. I am explaining the ultra high vacuum furnace, that is the integrated part of the advanced CNC micromachining system, in which the diamond grinding tool is in-house developed for the fabrication of the dental crown for the machining on the dental crown. That is manufactured in a vacuum furnace. This ultra high vacuum furnace is in-house developed with the ultra high vacuum capability up to 10⁻⁷ millibar of pressure. That is integrated with the PLC controller that is having that can control the current ranging from 0 to 100 ampere. That will increase the temperature of the furnace up to 1200 degrees centigrade.
When it comes to the machine readiness, it's already at the technology readiness level 6 because we have already done all the lab setups, lab testings, machine multiple materials, multiple components, and this machine is fully functional, ready to be operated within the industry. So we are looking forward that from this lab development, it should be directly go for commercialization. So the complete integrated software and hardware is working, perfectly tested by the PhD students in last 3-4 years. So machine has already gone through the rigorous testing on different material and different components. Yeah, when it comes to the market, certainly there is a big market for such machine tools. There is no machine tool available in international market which has a capability to do so many machining processes in one single equipment. This machine has a capability to machine multiple materials, multiple shapes with the different machining processes, and it has a tremendous application in multiple industries, whether it comes to the medical devices, whether it comes to the aerospace, micro hole manufacturing, micro channel manufacturing, microfluidics. So there are plenty of applications for such equipment in the market. Yeah, when it comes to the competitive advantage of such developments in India, certainly the significant reduction in the cost of the technology, the ownership of the whole technology is very competitive as compared to the international market. Moreover, we have the technology know-how within the India only, so we will be able to replicate such systems very fast and it can be maintained very well within the industry. Yeah, when it comes to the social impact of such machine tool is tremendous because Indian manufacturing industry is looking forward for such machine tool, and having such development indigenously done and in India is a unique outcome of this whole technology development. We will be able to make such machines at a very competitive pricing and which can be easily affordable by Indian market.